I'll begin with a scripture verse today. So this is Romans 5:8. But God demonstrates his own love for us in that while we were yet sinners, Christ died for us. I think it's a good verse to start with. It's a good one to remember. I'll begin with a word of prayer. So, Heavenly Father, we just thank you for this day. I thank you for this class, for these students. Just ask you to just bless this semester. Help us to glorify you each day in what we do, Lord. In your name I pray, Lord Jesus. Amen. All right, so let me, let's see here, order of operations. I'm going to come back to the quiz after we've gone over course policies. That's probably for the best. This is my website, supermath.info. As you can see, it's HTML 1995, something like that. I stand by it. In this, you'll find my office hours. So I teach. Where are we? We're here right now, and we meet 5 days a week. And so my office hours, I have 2 office hours that I'm holding in the game room down in the Montview, and so if you want to, you can come to those. And you can actually ask me homework questions in there if you want, but I'm probably not going to have my book and stuff, so you better bring yours. Then I also have a slightly more serious office hour from 3 till 4 after I'm done teaching physics. Sorry. There's another professor here who calls it physics, and it's rubbed off on me. But it's not right. Physics here, and then I have office hour 3 to 4. My office is in DeMoss Hall 4382M, which is code for go out the door, take a left, and go to the very end of the hallway. The interdisciplinary suite is where my office is. I'm currently exiled from the math department because I left here for a couple of years. Let's see here. I have taught Calculus 1 many times, but not recently. So you guys are my current guinea pigs. That's not true. I taught it like 2 years ago. But that was in Alabama, so it's kind of a different story. And I had like 2 to 4 students. Slightly different situation. But students are students, Anyway, and I also have office hours Tuesday, Thursday from 11 till 2. And again, so like the deal with office hours is you do your homework, you find questions, you bring me questions. What you don't do is come to my office hours to work problems. That's not what my office hours are for. I'm not a tutor. I'm here to answer questions for you, not to like work problems for you. So you have questions, you bring them to me, that's fine. But don't expect to come to my office to work problems. Like some professors do that, I don't do that. I don't think it's good for you guys to do that. I think you should work problems out on your own. Or you attempt them, you get stuck, you bring me questions, that's fine, all right? I'm happy to have students come to my office hours. Okay, so the course website is linked here. I made an announcement with a lot of these links too, right? So there's links to the stuff in Canvas, but I'm just going to stick here for a second. The playlist on YouTube, here it is. Exciting, yes? As you know, there's this thing called causality, which means that I can't violate the time ordering of events. Like, there's no way for me to post videos that I haven't taken yet in this playlist, so that's why it's empty. But after today, there should be a video here of what I'm talking to you about right now. So there's that. And I try to update it like every day. I post a video here. So if you're sick, by all means, stay home. You don't have to come here and share your cough with us, right? Like, you can stay home and get better and watch the video. I don't typically run Teams meetings during when you're sick or something because, if you're sick, maybe you should just be like sleeping in until noon and like getting better as opposed to like going to some meeting which doesn't really effectually make you part of the class anyway. So this, on the other hand, will give you a pretty decent, for the most part, recording of the lecture. I have a good camera that I think for the most part captures calculations, and I use a lapel mic so you can actually hear me. Unless my batteries run out, and my apologies in advance. Okay, so that's the playlist, the course website. This is actually my Calc 1 website. I have, like below here, I have oodles of like old tests, old homework solutions. I have probably a couple hundred problems solved from Stewart's calculus of some edition in the past. It's all the same calculus. It doesn't really matter. You don't really need a textbook in here for this section, in the sense that like I have course notes which I would provide. They're linked right here. I have them open over here. Let me look at it for a second here. It's like this is my lecture notes, calculus. It's 282 pages. It's a book. It's got everything in there. It's got proofs. It's got examples. It reflects the order of the course. It's how I think. It's really what you should study primarily, as opposed to Stewart. All right. Now Stewart's great. If you need a second opinion, if you want to read more examples, more homework problems, great, fine. But even that, maybe not, because here's your mission. Now what's a mission? Well, the mission is the homework that I would like for you to do. Now I'm not a moron. Like I'm not going to collect all of this homework because there's a lot. Like the totality of the homework that I have put in the missions this semester is something like 400 problems. All right, which is a drop in the bucket, like compared to a calculus book has 4,000 or 5,000, maybe 8,000, depending on the calculus book, right? If you worked all those problems, you'd be very good at calculus. If you work my 400 problems, you'll also be very good at calculus. Will you have time to work all 400 of these problems? I don't know. But you should work as many as you can. You should certainly work as many. You should work as many as that you feel like you're not going to learn anything from the next problem. Like when you get to a point in the problem, you're like, all right, I know what's going on here. I don't really need to do another one of these. Fine, go on to the next topic. But otherwise, it would be wise to work as many of them as you have time for. I won't collect all of them. You're like, well, then how are you going to grade the homework? Well, that's a great question. And the answer is I'm going to announce a subset of these that are going to be collected like about 2 days before the homework is due. So I would highly advise you don't wait until that to just do those problems. That would be foolish, and that will not prepare you for my test. It will not. You need to work a significant portion of these. Now, you can ask me about any of these, in class, out of class, right? It's fine. It's like totally acceptable. Most classes, with a few exceptions here and there where I got to prove something or I've got something on my agenda I have to get done, whatever, but by and large, if you come in here and you're like, Professor Cook, like, can you tell me how to work problem such and so forth? And I'll look it up and we can talk about it, all right? We have time in here to talk about your problems. This class is your class, all right? This is one of the advantages of taking this class in class versus online, right? You have a ton of contact hours with me every week. You can take advantage of those to ask questions, right? There's no 24-hour delay or whatever. Any questions? All right, well. The course planner is, hey, I did actually print you out a copy of the course planner. Maybe I should actually hand it out. What do you think? That'd be good. Or did I? Oh, really? Oh, man. Well, that's annoying. I see what I did. I printed the course planner out for the other class. I forgot to give it out. And I printed it for my class later this day, and I forgot to, well, maybe I'll remember to give it to them. I'll try to bring it to you guys tomorrow, a printout of this, okay? But anyway, this is the course planner. It's basically a syllabus except useful in the sense that it doesn't have all of that like boilerplate bloat that all the usual syllabuses have in terms of like policies no one cares about, stuff like that. This just has the day by day of what we're planning to do in here. So like day one, you guys have quiz one, which you guys have already experienced, and then what is calculus. And then like this is day by day what I'm hoping to cover. The chapter one that refers to the calculus notes that I had up, it's a PDF, right? So it's free, yeah. And then like, let's see, what's the next sort of big thing that's worth points to you, right? Mission one is due when? Next Tuesday. So I'll probably announce which homework problems I'm collecting, something like Saturday, Sunday, something like that. I'm not sure exactly. Maybe even Friday. It depends on how the week goes. Yeah, and then we'll have quiz one, which would be next Monday. And that quiz one will be based on the material that we go over Tuesday through Friday, all right? And possibly the homework problems that I'm hoping you're kind of trying, right? Any questions? let me talk about so there are 4 tests in here. They're all in class. They're all timed. You're like, what do you mean they're timed? Like, yes, tests are timed. Every so often I run into somebody who's been at some school where they somehow have untimed tests, and I'm like, no, the test by nature is a time pressure event. Like, that's kind of the point of a test. Because in the age of the internet, we can all do anything if we have unlimited time, right? So, I hope. Anyway, so test 1, test 2, test 3, test 4, all worth 120 points. The missions are worth 200 points. There's 10 of them. So like each one is worth 20 points, I think, if I remember correctly. The quizzes are 80 points. However, there are 11 quizzes. So the way this works is I'm dropping lowest quiz grades, like probably today for a lot of you. You know, so for example, for quizzes 1, 2, 3, 4, I just take the top 3 scores and count it for your final grade. All right. So like you just gotta do better on the next 3, and then whatever happened today will be erased. Now there is 20% bonus points in this quiz anyway. So if you got 80% of it, you'd still have like a 95-ish. All right. But maybe that didn't happen. That's okay. We're all getting started, right? And what else? The final is comprehensive. It's worth 240 points. I did notice at least one of you had the wrong kind of calculator. Like the calculator you're allowed to have in here in tests and quizzes is one of these guys, like a scientific calculator. So some of you have graphing calculators. Those are not allowed, unfortunately, like that big one. But I let it slide for today, obviously. But in the future, you need either one of these or borrow one of these from somebody that you know, something like that. We do have hideous pink calculators you can borrow from the math department. I'm going to try to get us to start charging for those to discourage students from using them. But other people say there's some kind of like tax problems or something with that, or some kind of, we're not allowed to charge money. I don't know. I think we should charge money. We could, after a while, we could have like a pizza party in the math department or something, you know, I don't know. All right, any questions? Nobody? All right. I will take attendance with Top Hat like starting next week. But as a generic point of order, like I almost never take points off for missed classes, but it's foolish to miss classes. All right. But if you do need to like go to a cousin's wedding or something in Montana, by all means, go. Just make sure you watch the videos when you're missing. All right. And if you're going to miss a test or something, well, then we need to talk about that. All right. Let's see here. What else should I show you? All right, so let's talk about the quiz. Let's talk about the solution to the quiz. So that's okay. I have the same one. Let's see here. So problem 1. So let's get to it here. I seem to have forgotten my laser. All right, so I'll use this instead. So this is the difference of squares. It's x squared plus 4 times x squared minus 4. Then this factors x plus 2, x minus 2, like so. This one does not factor nicely, but we can use the technique of completing the square, which is we take half of that and we subtract the square of it. So this is just an identity, which gives you a difference of squares, which then you can factor. Now some of you have written x equals minus 4 plus or minus the square root of 15. That is the solution to the corresponding equation. That is not factoring. There is a difference. Factoring is factoring. Solving is solving. These are related, but they're not the same, right? This is the fundamental confusion of college algebra. If this is your mistake, that's an easy one to fix, right? If you solved it instead of factored it, I mean, it's a serious conceptual error, but it's an easy one to fix, all right? This one is prime. I complete the square, and I get plus 2. Well, if you complete the square and you get plus, that means it can't be factored over the reals. You'd have to use complex numbers to factor that one, so it's prime. This one here, factor out x squared, and then if you complete the square, well, you just get that. It's x plus 3 squared, so that's all there is there. Problem 2, we can use the sign chart method. So the critical numbers here are minus 7 and 8. I can't have 8 because that would be division by 0, so I must exclude that from my solution set. On the other hand, minus 7, that's fine. That just gives me 0 in the numerator, which gives me a 0 for the fraction. So my solution is minus infinity to minus 7, and then 8 to infinity. The logic for this is the intermediate value theorem, which we'll talk about in about a week. Problem 3, this is a case-wise defined function, so we plug in 0 because we're in the first case, x is less than 1, 0 is less than 1, right? So cosine of 0 is 1. 2 is greater than 1, so we use the second formula, 1 plus the secant of 2 pi. Well, that's 1 plus 1 over cosine 2 pi. Of course, cosine 2 pi is 1. We should know this without a calculator. 1 plus 1 is 2. Yeah, so 1 and 2. Problem 4, excuse me. This is a composition problem. So f composed with g of 5 is f of g of 5, but g of 5 is 2 times 5 minus 1, which is 9. And then I plug 9 into the formula for f. That gives me 9 squared plus square root of 9, which is also known as 81 plus 3, which is 84. Sorry I didn't scramble these. I know it's a little bit off-putting. I do this sometimes. This is why I try not to do multiple choice in here too much, because I always forget to scramble the multiple choice, and then it leads to this sort of crisis of confidence. Is it really A, B, C, D? And then there's another one which is A, B, C, D. Could it be the case? Do you actually put 2 that are A, B, C, D? Don't think so hard. I'm lazy. Okay, so it's not that I'm lazy, really. I forget to change things. So anyway, as you look at these, 2 of them are clearly quadratics, and the other 2 are clearly rational functions. This one's a volcano, which means it's got like a quadratic in the denominator. This one is something like a hyperbola. That's just like a reciprocal function. So the B has to be that one. A is this one, because it's got a positive coefficient. It opens up, right? It's got a y-intercept, which is negative. This one's got a y-intercept, which is positive, but it opens down, so it's clearly that one. And you can see all of these in terms of just transformations of graphs. In terms of shifting horizontally and vertically, you can understand all of those formulas from transformations of graphs. Problem 6, this is, do you know what time it is in trigonometry? So tangent, if you've had trigonometry at precalculus, you should know that's tangent, right? The others are not. And this is either sine or cosine. A moment's reflection will reveal that that's sine. And this has got cosine of 0 is minus 1, which means this is cosine, the minus cosine rather. So that's why that one is. And this one is the tangent graph flipped over. That's the inverse tangent. That's the graph of inverse tangent, which goes to like pi over 2 that way and minus pi over 2 that way. And the limits as x goes to plus or minus infinity. Problem 7 here. We've got literally f of x times cosine of x is a, and g of e to the x is that. See, g to the x is the square root of x squared plus 1, so this is e to the g of x. So that is literally e to the g of x. And if we plug in cosine into x for the formula for f, we get this. So it's literally d. It's a, b, c, d. I'm sorry. I meant to scramble it. I'm sorry. Now this one here, if you didn't get this, this is kind of like, it hurts to see this, right? But it really wasn't that bad. Like, you just have to factor out the sine, and then that gives you a cosine squared plus sine squared times sine over or cosecant. But that's sine over 1 over sine, which is sine squared, and then sine squared plus cosine squared, well, it's 1. So really just algebra definition of cosecant and the Pythagorean identity there. This one here, students always have trouble with this, but this actually matters because calculus is a lot about pattern recognition. You need to understand what the pattern is, what the power is that you're looking at. We can't apply a power rule unless we understand what power we're dealing with. And so, like, this is the first order of business, is getting down laws of exponents. And students inevitably are weak on this. And it's not unusual for me to see a student who makes an A in this course get this problem totally wrong at the start. And it's just because you're unaccustomed to this problem type, right? Partly that. But anyway, so we just simplify, use laws of exponents, and then look at it, and you got 5/3 in the front, x to the 0, y to the minus 2. So that means I've got no x, so x is the exponent on x is 0, the exponent on y is minus 2, and the multiplication out front is 5/3. This one, when I square 2x plus the square root of y, cube it, I get 2 cubes to 8, x cubes to x cubed, of course, y to the 1/2 to the 3rd power is I to the 3/2, and then I use laws of exponents, and I've got 8, 5, 3/2. Right. I'm actually a little bit more concerned if you couldn't do problem 10. Not doing problem 10 means that you're weak in algebra And that might be an actual problem for you in here. Because if you couldn't do problem 10, and if you just didn't happen to see something, that's one thing. But if you really are genuinely confused by what I'm doing in problem 10, this is going to be a very difficult course for you to succeed in. All right? So I'm just trying to warn you ahead of time. You know, this course is not a sprint, it's a marathon. And we just keep learning new things. All right? So if you don't already know precalculus coming into here, if you're just rusty, that's one thing. But if you genuinely don't know, then maybe you should go back to like Math 128 or something, right? I can't kick you out. I'm not going to. I don't want to. I want you to succeed in here, right? But anyway, so this one, when we have a difference in the numerator, we can just break the fraction up like so. X cubed over x minus x squared over x. And the other two I just left alone. Of course, x cubed over x is x squared over x is x. And so we end up with plus and minus the x squared. Those cancel. 2x minus x is just x. This one, x squared minus 9, we factor as x plus 3 times x minus 3. We multiply then. When we multiply, we have to distribute. You can't just cancel one of them on one of the factors. That's a bad algebra mistake if you made it. Anyway, so when I distribute, I get this times that. Of course, these guys cancel, and those guys cancel, and you're just left with x plus 3 minus x minus 3. Parentheses are our friends. Important. The x's cancel, but the 3 and minus 3 gives us 6. So that's what that happens there. Problem 11 and 12 are sort of entry-level trigonometry problems. And you may or may not have got them, but so like not getting problem 11 and 12, I'm not super concerned if you didn't get these, but you'd like to be able to get them by the end of the course, all right? Like this is things that if you don't already know, you need to learn. So what I'm trying to say is a deficiency in trigonometry can be overcome in here somewhat easily, but a deficiency in algebra is hard to fix in the middle of calculus 1. Yeah. Anyway, so if you use your calculator, inverse cosine of a half is pi over 3, but that's only half the story, right? Because graphically, this is, you know, cosine, and so there are two solutions, one here and one there. And so I get plus or minus pi over 3 as my solutions given the context, namely that, you know, theta is between plus or minus pi over 2. And then this one here, since we're in quadrant 2, that means that that's where x is negative. Excuse me, I should say really, my bad. This is I should put a theta here just so I could talk about this more cogently, but this is in quadrant 2 if the standard angle is between pi over 2 and pi, right? So that's where the sine is positive and the cosine is negative of the standard angle. So when I solve for cosine, I keep the negative root, and I get like minus root 3 over 2. You can see that, of course, from your handy-dandy like unit circle that you guys probably memorized in trigonometry. I don't have that thing memorized, but I think through it. So, oh, and we're out of time. But anyway, so just to get started, I didn't tell you what calculus was. I'm so sorry. But in a nutshell, there's two problems in calculus: the area problem and the tangent problem, right? We're going to learn how to calculate areas under curves and how to understand the tangent line to a function. And my apologies that I didn't say more about that today, but here we are.